Hi everyone, today I'm going to be talking about multiplying exponents with the same base. So here we have y to the fifth times y to the eighth as our problem. And the question wants us to simplify and express your answer using positive exponents. So first we want to start thinking about, do we have the same base here? And the answer is yes, it is y. And our exponents are 5 and 8. So when you're multiplying the exponents, so in this case we have 5 and 8, with the same base, in this case y, we just keep our base y and we add the exponents, 5 plus 8. And we get 5 plus 8 is 13. So we just have y to the 13th. Okay? Another way to think about this is, well, y to the fifth is y times y times y 5 times. And y to the eighth is y times 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 y 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And how many y's do we have here? If you count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13th, you get y to the 13th. Okay? So that's the reason why when you multiply exponents with the same base, you just add them. Okay? So let's see if our answer is correct. And indeed it is. Okay, so here's another example. Okay, here we have d to the fifth times d to the fifth. Okay, again, if you're not sure, you can always break them up. D times d, d to the fifth is d times d times d 5 times. Okay, and the second d to the fifth, again, is d times d times d 5 times. And if you count them all up, how many d's do we have? Well, indeed, we have d to the 10th. Right? So the shortcut way of thinking about this is d to the 5 plus 5. And we get d to the 10th as well. Okay? Here's another problem. In this example, we have h times h. Now, remember, anytime we have a variable like x, we really mean x to the first power. We just sometimes don't write it sometimes. So really, this is h to the first power times h to the first power. Okay. And here, what is our similar base? It's h. Okay. So we're going to keep our base and then add our exponents. 1 plus 1, and we get h to the second power. Again, h to the first power is just h times h to the first power is just h times h. We know it's h squared, or h to the second power. Okay. Let's check our answer. Here's another example. Here we have s times s to the negative fifth power. Now first, remember, when we say s, we really mean s to the first power here. Okay, again, what is our similar base here? It's s. And our exponents are 1 and negative 5. Okay, so again, we're going to keep our base here. In this case, it's s. And we have 1 plus negative 5. Okay, so this is the same thing as s to the 1 minus 5. And 1 minus 5 is negative 4. So we have s to the negative 4 power. Now let's read what the question says. Simplify, express your answer as a single term without a denominator. So in a later video, I'll talk about how we can rewrite this negative exponent as a fraction. But for now, for this particular problem, you can leave it as s to the negative 4 because it doesn't want a denominator. So s to the negative 4, we can rewrite this using positive exponents by kicking it down as in the denominator. So it's the same thing as 1 over s to the positive 4 power. So the negative disappears and we kick it down into the basement, into the bottom. Okay, I'll talk about this in a later video, but the question says they don't want a denominator, so they probably just want us to leave it as a negative exponent. Okay? S to the negative 4. Here's another example. Here we have v to the negative 9 times v to the negative 5. Again, we want to start thinking about do we have a similar base here? Yes, in this case it's v. Okay, so remember our rule. When we multiply exponents with the same base, we keep our base and we add our exponents. So in this case, we have negative 9 plus negative 5, which is the same thing as v to the negative 9 minus 5. So this is v. Negative 9 minus 5 is negative 14. So we're left with v to the negative 14. Okay? You can leave your answer like this for now. Okay? We will talk about negative exponents in another video. So here they just want us to express your answer without a denominator. Okay, so let's put that in. Okay, so let's do one more. So this particular problem, we have q to the 0 times q. Now remember, q is the same thing as q to the first power. Okay? What is our similar base here? It's q. Okay? Alright, so when we multiply exponents with the same base, we keep our base and we add the exponents. In this case, 0 plus 1. I'm left with q to the first power. Okay? Or just q. And for those who are curious, anything to the 0th power is just 1. Okay? X to the 0, 10 to the 0, 1000 to the 0th. All of this is just 1. So what we are really doing here is we're doing 1 times q to the first power, and that's just q to the first power. Okay? Let's put that in. Just q to the first power, or I'll just put q.